Take the helm.
All right. Sharing screen.
And we're not working on conveyor belt. We're working on
rxRust.
rxRust,
Oh.
doing an on the catch error.
Yeah.
So you can fetch,
Mhm.
and you can start the timer.
Oh, catch error. Check out catch error and start the timer. Mob start. Yeah. Yeah. So git log as it's in the catch error. Oh, so we started working on catch error, is it? Okay. Did the maintainers respond regarding that, or I'm not?
Yes.
Okay, they're okay with external contribution, I suppose. Yeah.
Yes, and we got a recommendation to start by looking at the retry operator.
Mm-hmm.
Okay, sorry, I did some window management.
Uh-huh.
So let's just go and read retry.
Okay. Ops retry. Uh-huh. This module provides the retry operator. Okay. Simple retry with count.
Yeah. So just explain this to us, everything.
Okay. There's an RC. And then we create.
Hold on, don't
Yeah.
be stingy. Be generous with how you explain this.
Oh, okay.
Like, yeah.
Yeah. We create an RC to track the number of attempts, how many retries basically. And
RC of cell for some reason.
yeah.
What's the reason for using RC of self to make it to make it mutable, right? To give us mutable access.
Yes.
Okay.
Yeah. Then we
There's like
create
runtime borrow checking.
runtime borrow checking. Yeah. Right. And then we declare the source with source observable. Is it? Yeah. And we clone the RC in that scope. This is because
I guess we will see later.
modify. Yeah. And then we initialize the observable.
Oh, this is the most general way to create an observable with create. I never did that.
Yeah, I've not seen that either. Which takes a closure as an argument.
I bet it can take other things, maybe. It's probably generic in what, those are the last two
Yeah,
type parameters. They probably have to do with the function and its return type.
yeah.
You can like do control K on one of those, whatever it is. Show type of those underscores.
No hover results. No hover results.
Do you have anything?
Nothing. No. Maybe is the LSP even working? LSP
That's what I meant to ask.
restart. LSP restart. Oh,
Do you have the shelf things?
yeah.
Do you have the
I do.
toolchain,
Yes. I could.
including Clippy?
Yeah. Looks like it.
I don't
Oh
know.
no.
Isn't it the executable cargo Clippy?
Yeah. But this is what I have.
And it's working? Why do you have why do you have Usenix as well?
Oh, this. I think I just copied it from a
Mm-hmm.
conveyor belt. In conveyor belt, we have default Nix
Gotcha.
and shell Nix and
Okay, well, we don't
yeah.
need the unfree,
Yeah.
and we don't need the watch exec, I suppose.
Yes. And we don't need this.
Yeah, I don't know whether the additional Usenix did anything significant. Probably not.
Yeah. No, I just threw an error saying there's no default Nix or something.
Let's try that.
Didn't allow.
Okay,
Okay. Oh, I'll have to retry.
that looks better. Is it taking longer? No.
Oh, but is it
Is
because
Rust
it's
Analyzer part of that .env part of the shell?
it works on non-comment literals.
Oh, it was a darn
Yeah.
comment.
Yeah.
Okay. Sorry.
Uh, I thought it worked on comments. I'm not sure. Yeah.
Yeah. So we have syntax highlighting on comments, but we can't have
LSP.
LSP in comments.
Mm-hmm.
So we are misled.
Yeah.
By the maliciousness of missing features.
Mm-hmm.
Yeah, no need to rotate. Let's just read
Yeah.
through this.
All right. I could also go to the create itself if you want to look at
No,
definition.
no need.
Yeah. Okay.
I expect, you see the emitter.
Mm-hmm.
You can call error next and complete on that, and that's pretty much it. That's the API.
Okay. Yeah. Yeah. So inside the closure, we increment. We get the current value for number of attempts and increment it by 1, and then set that new value.
I see.
And
So
if
we first register
mm-hmm.
an attempt and then actually do it.
Yes. Yeah. If the number of attempts is less than 3, we emit an error, or we emit next, and
Okay, so we
yeah.
guarantee 3 errors.
Guarantee 3 errors.
Yeah, right. If n less than 3,
Mm-hmm. Oh yeah,
then
yes,
there will
yes.
be
Yeah.
1, 2, maybe 2.
I mean 0 when it's. Oh no, we are incrementing first. So yeah.
Yeah, it looks like 2 errors will occur.
Yes.
So that's why we have attempts count.
Mm-hmm.
And then it does 1 next and completes.
Yes.
So and And so this closure will be called when the observable is subscribed to.
Mm-hmm.
Each time the observable is, because that's what retry does. It subscribes to the observable again on error.
Yeah. Right. Oh,
Go
yeah.
on.
There's this. Okay. And now we create a new RC result with ref cell vec.
Uh-huh.
And what is this record struct? And then an implementation for observer for the record struct.
What is record?
That's an RF ref cell vec, which is what the result is meant to hold.
Mm-hmm. Okay.
Yeah. And then we implement observer for record. So, and the subsequent methods, required
Where
methods.
the value of the observer is I32 and the error is
Stir. Yeah.
the stir because of line 26.
Because of line 26. Yeah. Yes.
It also matches line 22. I32 and ref static stir.
Yeah. Oh, and next just pushes a value onto the vec. An error does nothing. Complete does nothing as well. And is closed always returns false.
Okay.
And then on the source observable, we retry thrice. Subscribe with the record. Oh, and then we clone the result here and assert if the result is a vec with one element with the value 1.
Okay. Solid test.
Mm-hmm.
I mean, it did not. Fine. I mean, good enough. It's the documentation test, so
yeah.
fine.
Right. Advanced retry with retry config. What is advanced here?
We don't need to. We have enough complexity.
Yeah.
I think this is like retry takes either a number or a retry config.
Oh, yeah. Okay.
Count, delay, reset on success, whatever, right? And so number internally probably gets, maybe it's like something like into retry config.
Yeah.
Okay. It can be interesting, but it's irrelevant, all this retry config stuff, right? I think the point is that it's, the rest of it is kind of similar to what catch error will do. So let's move on.
Yeah. Custom retry policy based on error type.
That sounds fancy. Let's move on from it.
Yeah. And then we have some create imports. And then policy for determining whether to retry an error. This trait allows customizing the retry behavior. Simple policies like usesize and complex policies like retry config are supported. Users can also implement this trait for custom retry logic. Huh. This also is not relevant, right? We don't have to.
I'm trying to stand my desk up,
Mhm.
but I just connected this new monitor, and I'm being very careful with the cables to see that they have enough length to support this standing up.
Mhm.
Otherwise, the desk does have like a feature where it stops, but
Yeah, I have a standing desk with a manual lever. I have to rotate it to make it go up.
yeah, I actually I saw one of those, and I was like, damn, I want to replace it with one that has an engine, a
Yeah.
motor, electric motor. And then I said, if I don't get that, I want to bring uh, a cordless drill
Mhm.
and attach something and use the cordless drill to.
Yeah. I just wanted easy repairability if something went wrong, but I don't know how often they go wrong with engine-based standing desks.
I totally agree. But I want to try the cordless drill trick.
Yeah. Okay. Um, so do we have this retry custom policy?
Not relevant. I'll
Not
skip
relevant.
it.
Yes. And the same thing, but now a configuration struct for retry. Build a pattern for creating a retry policy. Again, policy.
Not interesting.
Yeah. Retry config. No. Default retry config. Retry policy. And the retry struct, which
That's interesting.
yeah, which has a source of type S, policy, and scheduler.
Yeah. So the source is relevant
Mhm.
because it's like when you call you use operator, it it consumes the observable you call it on
Yeah.
and returns a wrapper. This is the wrapper, retry. And S, the source S is the wrapped, is the thing you called it on. It was consumed. Does that make sense?
Yeah.
So you end up with a chain of wrappers that call the inner one in turn, depending on the behavior. But like many times it's just a filter map, yada yada yada.
Mhm.
Eventually there's probably a producer, right? Like that create one.
Yeah.
That its implementation of observable is to actually do something, right?
Yes.
Okay, policy is like an irrelevant detail for us.
Yes.
And scheduler is this like
Probably.
rxRust detail, right?
Mhm.
That uses every operator needs a scheduler, I suppose. Which is also different from the context.
Yeah.
I'm not sure what its relationship to the context is, but you'll see there are like too many types. We will see more types here.
Yeah. Okay.
Here's the first type. We can see that
Observer.
there's a struct retry, and then there's a struct retry observer.
Mhm.
Because an operator has two sides, observable side and observer side, which observes the source observable. Does that make sense?
Yeah. Observes the source observable. Yes.
Mm-hmm. If I stop you and add information, then just proceed. Just
Yeah.
go on.
All right. We have the retry observer struct. The struct is public to satisfy type trait bounds in public API, but is considered an internal implementation detail of the retry operator. The user should not initiate or interact with the struct directly. Okay.
Mm-hmm.
The struct has source, policy, observer context, attempts. Policy and attempts are irrelevant for us, I think. Serial subscription, which comes from the observer context. Oh no, it's an RC mute. Okay. Boxed subscription, and then subscribe function, which takes a function of self. Oh, yeah.
So what do you think the source is?
The source,
Here it has no bounds.
yeah.
So because this is an observer, maybe the source is an observer. Maybe observables wrap observables and observers wrap observers. Does that make sense?
Yeah. Okay. Oh, so the source in observer, right? Got it. But this source will be an observable?
Maybe.
Okay.
The bounds are not here. The bounds are in the implementations.
Yes.
Policy is, we have the relevant detail. But I don't think that's correct because there's also an observer field. So I'm not buying it. Source probably not an or maybe this is like source is the source observer and observer is an observer context of which there is, I don't know, there's maybe only one or something. And because this is a type, not a this is a type of a field, not a trait. Right?
Type of a field, yeah, of observer, yeah.
What is observer context? It kind of sounds like a trait, but oh, it is
context.
specific to it's specific to this operator.
Yeah.
Not the context, the struct observer context is a retry observer context.
Okay, yeah.
Hold on, it's a type parameter.
Looks more like an alias.
Look at 273.
Yeah.
That's where it comes from. It's a type parameter. So most type parameters are like single letters. This one is 2 words.
Yeah.
Okay. I get it.
Yeah.
Why do you think why do you think you have a serial subscription for retry, which is a observer context RC mute? RC mute tells me this will be cloned, right?
Yes.
And it might have. Maybe it's for like passing it around between them. Because if you have a RC mute option, you can like at runtime pass the value that may be in the option from one to another. But I don't know why you'd need an RC mute for that.
If you want to have multiple copies of them.
I think the RC mute here is an implementation or a design feature or detail of this observer context of how observer contexts are. It is like at a type level. I remember this. This is so observer context is a context, right? Line 275, and because it's a context, it has an associated type, RC mute. Can you go to the declaration? Yeah. Because it's a context, it has an associated. You see it, all these associated types. One of them is RC mute, the fourth one.
Yeah.
So this is all like details that have to do with the context. And here we hold the RC mute of the context. And it is generic as well.
Yeah.
Okay. I guess that's all we can understand now. And what about this subscribe function?
It's a function that takes the retry observer as an argument. Function
It's to avoid
pointers.
circular type bounds requirements. Oh, because it's because you can't take, it cannot be self. So you put it, you do function self. This looks like a type hack.
Yeah.
Somewhat beyond me to understand why you even want. Yeah, I don't know. I don't know what this is. Well, fn is a function pointer. You don't need to read much about it. Okay.
Yeah. And then we implement observable type for the retry struct.
Observable type. Yeah, I remember. We are going to implement observable type trait, and another trait is called core observable. Both of them will be implemented for the retry struct, if I remember correctly.
Okay. Yeah, we do have observable type, but
we have two.
Two.
One is for retry, and one for retry observer. For some reason.
Yeah.
For some reason, the observer is also an observable.
Right. Oh yeah.
But let's look at those implementations, and that's core observable.
For
like
retry.
I said, for retry.
Yes.
So let's look at let's not skip things.
It's You don't want to skip this observable type?
I don't want to skip either of them.
Okay. Yeah. First observable type for retry struct.
The only bound
Is the observable type parameter.
is that S, which remember ends up as the source field, is also observable type.
Yes.
P is for policy and scheduler.
Yeah, though they can be generic.
The
And
associated type item. Sorry, I'm just.
Yeah.
If you want to do, I'm thinking, like, is it taking you as long as it's taking you because you're thinking, or because you're not sure I'm finished and you're waiting for me?
Yeah, no, I was thinking.
Okay.
This is also the first time I'm seeing this code base, so I'm a bit blank. Yeah. Yeah, gone.
There's an observable, there's an associated type item. And the associated type item of observable type trait is generic on a lifetime. So this syntax is not entirely clear to me, because where is a lifetime A declared, seems to be in line 290. It kind of looks odd to be able to declare it there, but I think that is the case. That's where it's declared, and then it's used in the next line. So and this is like inheriting the item type, right? That's what it does. It's inheriting the item type from the source from the implementation of observable type of the source observable type, right?
Yeah.
And it says also that it couples the lifetimes. Itself must outlive that lifetime. Okay.
Yeah.
Fine. And then it inherits the associated type air from the source observable type.
Okay. Yes.
Impl observable type for retry observer, we have SPO. They are immediately passed on to the retry observer. And the retry observer, we wondered what S is, and here we see that it is an observable type. So both in retry and retry observer, S are observable type. Even though it's an observer, it has a field that is an observable type. Okay?
Yeah, okay.
P is the policy, and O is the context. So while retry, the thing you get back from it's not quite the thing that you get back from the operator, but still. Retry, which is considered the operator struct, does not hold context. It holds a scheduler. Source to policy in the scheduler, and the observer, retry observer, holds a source to policy and the context. the item is inherited and the lifetime is bound.
Mhm.
The error type is inherited as well.
Yeah, makes sense.
Impl core observable for retry. This is where the context is involved, and this is where the most of the implementation is, I suppose. We have source, policy, scheduler, and context,
Mhm.
right? All four, I suppose. The like it's like the union between the types that retry and retry observer have, right?
Yeah.
Core observable, the trait we're implementing, gets the context,
Mhm.
because that's what they take. Core observable. That's what core observable, I think, is what has all the methods, right? Map, filter, and so on. That's what the operators are on, and subscribe as well, right?
Yeah.
So that takes the context, only the context, and the retry takes the rest of them: source, policy, and scheduler. We happy about this?
Yeah.
Okay. There are a bunch of bounds here. Context must be a context, which makes sense. Source. Wait, love, don't bark. Don't bark, please. Don't bark. Be a podcast dog. Okay? Studio dog. Core observable. S is also a core. So S here is not observable type in this implementation, right?
Yeah.
In the implementation of observable type, S is bound by observable type. In the implementation of core observable, S is bound by core observable.
Yes.
And since core observable needs context, I think what we're doing here is passing on the context of the source. Does that make sense?
Context of the source.
Yeah, this is, there's like, it's like a step removed. So CTX is our generic that implements context.
Mhm.
And there's an associated type with
Yeah.
on these. And it is generic. And this apparently is where we pass on, is where we pass the observer type, our observer type. Right? Look, we are
Yeah.
implementing core observable for retry, it's the operator type,
Mhm.
or maybe the observable type. We can call it the observable type, retry.
Yeah.
And in its implementation for core observable, implementation of core observable for it, we are binding or bounding the source core observable.
Yeah.
The S. Oh, okay. So I think I understand. So actually this is like, I think it's like kind of wrapping it twice.
Mhm.
The origin, the real source is wrapped in an observer to observe it. Right? Like whatever we call the method on, right? Whatever we call retry on,
Yeah.
will be mapped with a retry observer.
Mhm.
Retry observer, in turn, implements observable type right above this, right?
Yes.
And then the retry holds a retry observer, but that is not a bound, like, because it is like this is deferred, right? Like it's like you could ask, why is that not like made concrete somewhere, that retry has a field that holds, a retry observer somehow?
Yeah.
Which I cannot answer, but like I'm also not suspecting that this is wrong. I'm just making an observation that the fact that that field will have a retry observer inside of it somehow is here, is bound here.
Yeah.
So it is a core observable that has a context with, I don't know, can you say, we can like not understand this pattern, the context with pattern entirely, or we could try to understand it more. One thing I would like to do is like look at that with in the trait. Like if you go to the type, it's of course an associated type on core observable, right?
Yeah.
No, on context. What is it? What is this on?
On context, yes. It's
On
on context. Yeah.
It's generic on T. The bound is context, and not only context, but that the inner of the context is T, and that the scope is self-scope, which whatever scope means at all, and that the scheduler is self-scheduler. Quite a web of types we have here.
Yeah.
Okay. This doesn't explain much to me, so let's get back.
Yes.
Okay, and the retry observer gets the S, the source, which is an observable type, the policy, and the context. And it needs to be cloned.
Yeah.
Okay. This is a bound on not S itself, but on S unsub. The unsub associated type. So the unsub of the context, of the core observable. It needs to implement into boxed subscription. For each of these bounds, we expect to see some method call later on, right, in the body?
Yes.
So, we guess we'll see that. And into box subscription is generic on the text as an argument, the box subscription of that context, which I don't know, makes sense. The last bound is context RC mute. The RC mute of the context.
Yeah. Yeah, right.
I know. Did I ever see such a trade bound that is like a trade bound on something that takes? Yeah. So like, it's not a trade bound on just any RC mute. We're making context RC mute concrete here. It takes option of CTX box subscription. I think this is like a bound that might already exist, but we just, just because, I don't know, of semantics, you have to specify a type argument.
Yeah.
In any case, this must hold, right? That an RC, that a context RC mute of option context box subscription must implement subscription. Okay. Shall we look at the implementation of core observable?
Yes.
There's an associated type unsub, which we say is a context RC mute in this case.
Uh-huh.
So this uses the type from the context type argument, right? Type parameter. It's mute of option of context box subscription. Okay. Whatever. I guess there are other, there are more alternatives to this.
Mm-hmm. Is this supposed to be like the unsub in the source type? How are they related?
Maybe we are like taking it or cloning it or just using it. I don't know.
Mm-hmm.
Good question. So let's take a look at the only method here. Subscribe.
Yes.
So that's the only required method, right? That doesn't have a default implementation in core observable. It seems, right? Because if the only method that is declared that is implemented here, then it must be the only required method.
Yeah.
So the signature is that it consumes self and
Mm-hmm.
consumes an observer. And the observer is the context,
Yes.
right? So subscribing consumes both the observable, the core observable, and the context. They are coupled together, like that.
Yeah.
Which makes me think that like this is not because I don't think when you call subscribe you pass. Oh, yeah, you just pass an observer, and you must pass an observer of a context that matches. Does that make sense?
Yes. Yeah.
Okay, and then you get the unsub to be able to unsubscribe.
Mm-hmm.
Okay, let serial subscription context RC mute from none. Okay, let retry observer. So we make an empty subscription, right? Like a non-subscription.
Uh-huh.
I don't know why it's serial, but it's redone. Let retry observer is a retry observer. So in order to start subscribing, we need to this thing. What are we implementing for again? The retry.
Yeah.
Okay, in order to subscribe, right? To like actually start observing on a retry, a retry observer is constructed. So this is where the observer companion of an operator, the observer companion of an observable is constructed. It's constructed in the subscribe. I don't know if that's always the case, but it's the case here.
Mm-hmm.
Is it helpful that I'm narrating it this way?
Yeah.
Okay. The source field comes from, yep, so it just consumes the whatever it was, the
Whatever called
source.
subscribe. Yeah.
So yeah, so so subscribing breaks the retry struct apart
Mm-hmm.
and instead constructs a retry observer. That makes sense?
Mm-hmm. Yes.
That I think that's that's like useful for my mental model. That feels like that part of it, makes a good image of that happening. So the source is taken to be the source of the observer, the policy as well, the observer that was provided to, for observing is wrapped, right? Is wrapped by the retry observer struct.
Yes.
Attempts is initialized at 0. The serial subscription is cloned. That means that it will be passed somewhere else as well. And it's none at the moment still. And then there's the strange subscribe function that we saw that simply consumes itself, right? It consumes self, where self is retry observer, obviously. And what is that? What is this? I don't understand what I'm saying. This is a function, associated function. I see. That's an associated function. We are that. So you remember that it's an lowercase fn?
Yeah.
This is it. This is the lowercase fn. This is a function pointer.
Function pointer. Yeah.
It's just we get it. This is how we get the function, because it's an associated function retry observer. So we access it on retry observer and you get the function pointer this way. And a function pointer is a static value, right? Okay. Let subscription equals. Okay, so we actually subscribe here. As soon as we've constructed that retry observer, we do retry observer source clone. And we can clone it because, I don't know, some trade bound allowed us to do that, right?
There is a trade bound.
Is it 312? At the end there, plus clone?
Yeah. Yes. I believe so.
So, that this means that, like, if you go up a little bit to the signature of the core observable, impl 309, core observable for retry.
Yeah.
It means that it means that only observables that can be cloned can be retried.
Yes. So which were the observables that cannot be cloned? We did try to use them. We tried to use some observables in conveyor belt which weren't.
Oh, you remembering something?
Oh yeah, no.
I'm not sure.
Yeah, never mind. Yeah.
So you see that we're not subscribing to the source. We're subscribing to the clone of the source. Thereby keeping a clone, keeping the original, right?
Yes.
So that we could retry, we could subscribe again, because again, subscribe consumes self, right? We can see that on 317.
Yeah.
Okay. And we can keep in mind that some observables, how do you get an observer? Usually it's something that does some IO, right? So it's up to the implementation of that observable whether it can be cloned. It's very simple to phrase it like that, right?
Yeah.
Right. Like if it's an observable that, like, I don't know. Does a database read? What's the reason it wouldn't be clone?
No reason.
But if it does some effect, like, I don't know, deleting files and like letting you know whether you successfully deleted them, then that wouldn't make sense that it's clone, right?
Yeah.
Or I don't know, maybe if it's idempotent, on the other hand, then it could be clone and then you could use retry.
Yeah.
Okay. Cool. So subscribe, clone and then subscribe. And the observer given to subscribe is context lift. The plot thickens.
Mm.
What the heck is that? And we call that with the inner argument to lift. That returns a self with.
Yeah.
It lifts a value into context with default scheduler producing self with you. So this is some sort of a constructor, yeah, right? Use this method when you want to create a context for a different value type U, but compatible with the current context family, same scheduler type. This is essential for operators that need to create contexts for transformed values. Okay, so it seems like a commonly used utility, right?
Yeah.
Retry observer that we have constructed 319. So we construct one, and then we consume it there, right? We pass it into subscribe.
Yeah.
It's gone. It's passed into, it is the single observer now. Okay, and we are subscribed, right? We have a subscription. And it's an impl into box subscription of something.
Yeah.
What do we do next? We subscribe and we have a subscription and we don't have the original observer anymore. But what we do have still is an RC of the serial subscription, which seems to be like what we need to keep. And what we do now with it is obtain a mutable reference.
Yeah.
And now we mute it. Now we reassign, right? The contents of that cell. I don't know if it's a cell, whatever. The contents of that RC mute. We reassign it from none to some subscription into boxed.
Yeah. Yeah, that makes.
And then we return that subscription. So all the. So we have simply subscribed, but there is no implementation here of actually observing where the magic happens, right? This is hooking things up.
Yeah.
Right? Like we in the implementation of observer, which comes next, 336. Seems to be the logic here of retrying, I would assume.
Yes.
So let's take a deep breath and dig into that.
All right.
Impl SP context item air.
Uh-huh.
We know what SP and context are, I suppose. Item is simply the, whatever the item of the value, right? Air
Yeah.
is the error type. And we are implementing observer of that item in air for our retry observer. Again, passing in SP, source, policy, and context.
Yeah.
The bounds are that self must be cloned. Now, retry observer is self, but not just retry observer of SP and context, right?
Yeah.
So the implementation of clone for SP and context, where is it? Can you go to the declaration of retry observer?
Yeah.
Is it just derive? It's not. If it's not, there must be an impl clone. Can you search for an impl clone?
Impl clone? No.
Well, it's generic. Search for clone. Or, go, you can do list implementations
Oh,
on retry observer. Yeah.
go to implementation. Oh,
Yeah.
no.
Yeah, that's fine. It'll give you a
Oh,
list.
okay. Yes.
So that's takes an inherent, right? We're not looking for
Yeah.
an inherent. That's the
This,
wrong trait.
yeah.
That's the wrong
So,
trait. It's the
no.
wrong trait. Oh, that's the right trait.
Oh, yeah. There's clone. Yes.
Okay,
Yeah.
so for retry observer to be cloned, S needs to be cloned, P needs to be cloned, and the context needs to be cloned. And context. I don't know why it needs to be context as well in here. Oh,
Yeah.
because we actually do something in cloning, which is probably important here. So let's read this while we're here. The way we clone the retry observer is that we have a reference to self, and then we clone the source because it's cloned. We clone the policy because it's cloned. Oh, this is just a value. We clone the observer because it's cloned.
Attempts is attempts. It's just I32, right?
It's a copy type. Yeah.
Yeah.
Serial subscription is also clone. And the subscribe function is just a function pointer.
Yeah, but I don't see where we need this. Why in this context bound?
Interesting. Maybe it's a useless bound. But it might, if you just remove it, you might have some errors, right?
Yeah.
We have better things to do than to figure out all the ways in which this
Yeah.
errors if we remove a bound.
Yeah.
We have to navigate the forest without naming all the trees. Okay, fine. Then it needs to be cloned for this to actually work. And I think it's actually hard, because if you obtain this, if this observer is constructed, I think that part is probably already guaranteed. But I'm just guessing. That makes sense?
Yeah.
Because the user does not construct a retry observer, right? They just call retry, and so I think and I think there's probably a bound on them, calling retry that guarantees that this will also be true. Does that make sense?
Yes.
It's like an earlier bound. Okay, so let's get back to observer. Yeah, that was
Oh,
it.
that was it. Yeah. Yeah.
Wait.
This
The,
is where we were.
okay, so self clone, right? That's what got us into the clone adventure.
Yeah.
Okay. P is the policy. Okay. Well, here it must actually be implementing a retry policy of that error. So apparently there's a trait, right? And that's, I think, important because user can, provide their own arbitrary implementations of retry policy.
Mm-hmm.
So there's that. Context is a context where the associated type scheduler is a schedule. Oh, so that's a struct here. Wait, what is that? What is scheduler? Can you just hover this?
Oh, or just
Not
hover
the associated type.
this
That
scheduler. Yeah.
it's a trait.
Yeah.
What am I looking at? It's like, can you explain this syntax? Like, we know it's a trait.
Yeah.
But because I know the syntax for a trait bound is like, okay, there's the generic type,
Mm-hmm.
there's a colon, and then on the right-hand side, there is a trait. I'm fine with that. Context is a trait, right?
Yeah.
But context here is a generic trait, which is also fine. And then scheduler is an associated type on context, which is also fine. But what's this colon? Is this a trait bound on? I mean,
Trait bound. Yeah.
like, is this an alternative syntax? Like, because if I wanted to introduce a trait bound on this, can you just ask an LLM what I'm looking at here? Because I just don't know the syntax.
Yeah.
Maybe even just the where and that line.
Yeah. Just this line. Yeah.
And yeah, the where is important, and that
Mm-hmm.
line. I don't get it.
I think it's, where's that Leo thing? Oh, I can just ask. And just explain the context or explain the CTX
Well,
bound.
I think you should omit the two previous.
Yeah.
You can run the search, edit the search string.
Right. Self is no. So where, just remove this and keep the context.
Mm-hmm. I want an explanation of the syntax for this.
Explain syntax.
Yeah.
Syntax for this.
Yeah.
Yeah.
Complex generic trait bound specifies any type of sound to context. Must satisfy three primary requirements. Must be a context. Okay. Associated scheduler must be configured in a must act as an observer. Okay. The core constraint, context, CTX context plus observer.
Mm-hmm.
Fine. Use what is it? Oh, use code. Context declares a generic trait bound. Any type to context a trait that requires specific contextual data plus the associated type constraint. Associated type constraint. Context scheduler. The context trait itself is generic and contains an associated type named scheduler. Scheduler. This enforces an inner trait bound on that. I mean, that's what we have assumed, right?
Yeah.
Inner trait bound on that associated type. It requires that context's internal scheduler type must implement the scheduler trait. Okay, fine. Good enough for me. I'm it's like confirms to a reasonable degree of certainty.
Right.
So the scheduler type is scheduler of task. What's task? Scheduler of task. I bet task is just another common helper struct. The state that data that persists across task executions. It's not from here, right? Like it's not from this module.
Yeah.
Okay. Scheduler of task of option of self. That's interesting. Okay. Plus observer. So the context is a context plus observer of item and error. Okay. Fine. This like probably just typical. Okay. And observer is where the interesting part is. So that's why we have a next, error, and complete.
Yeah.
Okay. Let's see next. Next is probably pretty simple. If self attempts greater than 0 and self policy reset on success. Okay. There's a method for the policy reset on success. Then we had a success, right? We got a value. So we reset the attempts. That seems typical, right?
Yeah.
And we then pass on. See, this is observer wrapping in another observer, right? So we just observe on the inner observer. Cool. Call next on value. Passing on the value.
Yes.
So the role of an observer is to handle a value being pushed to it, right? Via the next call, and to like either actually do something or to pass, if it's a wrapper, to pass on, right? Or some combination, right? This is a combination of actually doing something and passing on.
Yeah.
Eventually down the chain, there should be an observer that actually enjoys the value, right? Okay. Here is where the meat is. So let's read complete before we read this.
Yeah.
Okay.
Oh, there.
That's the simplest complete.
Yeah.
And is closed is also the simplest is closed. Okay?
Yeah.
All right. If let's so we call 358. We call self policy should retry because we got an error, right? And we can mutate self. So we ask the policy. We give it all the information that it needs. We give it all the information we have for it. So the generic information, the trait, right, takes the reference to the error and how many attempts. And then if the answer from the implementation of policy is that we should retry, right?
Yeah.
Then we are also provided a delay. duration. You see that?
Yes.
And so we increment attempts. We clone the scheduler of self. So apparently you can call scheduler on an observer.
Mm-hmm.
I'm not sure what trait that is from. Can you well, yeah, the that. Okay, context. That's from observer being a context.
Yeah.
Okay, so from a context, you can obtain a scheduler, and apparently you can clone this one. And here is this imperative thing, right?
Mm-hmm.
Schedule a task, a new task, clone the generic state. Okay, so the state of the task is is the self, is actually the self. Does that make sense?
Mm-hmm.
The state is self, and it's so the handler takes this, yeah, and
Uh-huh.
if let some, right, if the task was I don't know, executed with some observer, that's the retry observer,
Mm-hmm.
then we take. I'm sorry, that's what take does. Then we call the subscribe function. I have no idea what I don't get it. What the heck is this? This does nothing. It just consumes it. I don't get it.
Yeah.
What is?
It's a function pointer. But
Well, actually, hold on. We didn't read the subscribe function.
mm-hmm.
There is an implementation to this function pointer, right?
Yeah, subscribe impl. Yes. So
Sorry?
if I look at the implementations, and I think
At the construction. I mean, you can just text search it.
this one, right? Oh, not that.
It's I think it's core observable for it. Implementation
text.
core.
Oh.
Yeah, subscribe. That was it.
Mm-hmm.
Wait, what's subscribe impl? Oh, I think we found it, right? This is associated function subscribe impl. That's what is given as a function pointer when it's constructed. The observer is constructed. Then there's some magic here that we are not, it's not relevant to us. So I'm not inclined to spend the energy to understand what's going on here.
Mm-hmm. Yeah.
Okay, let's understand. Let's do it anyway. So this consumes self, and it has some bounds as well, but whatever. It clones the serial subscription
Mm-hmm.
that the observer has. And then it does again the same operation, right? Like attempt to take
Mm-hmm.
the self from the option and
Unsubscribe.
unsubscribe because it's a retry. So we unsubscribe if there is a subscription. Let's source equals clone the source, resubscribe, and that resubscription does the thing, triggers the same thing, right?
Yeah. Yeah.
Because this time subscribe is called not on the source. This is not the same. What am I saying?
It is the same.
I don't know, because look at 387.
Mm-hmm.
This is core observable context with self. So we're cloning a self. See, it's not the same type. This is not really the source. I mean, you could even make a better binding here. Let is kind of a let self, right? It is literally self clone, right?
Yeah.
So in this case, we are calling subscribe on a retry observer, not on the source. Does that make sense?
Yeah. Yeah.
And then we do this.
But okay.
Yeah.
I got it now.
And then we again take the subscription and place it inside the
Serial.
inside the serial subscription. Because we already sent self somewhere.
Mm-hmm.
It's like we already sent it somewhere, and then we mutate it after sending it somewhere, right? Like we called subscribe, so we consumed it, right?
Mm-hmm.
And then we placed the subscription into it, and then dropped that RC.
Yeah.
Okay, now I understand why it's called serial subscription. It's like the serialness of retries being serial and not concurrent, right?
Mm-hmm.
And it's a single value that whatever. Okay, so that happens, and there's another argument there. Task state.
Yeah.
Don't know why it's finished. I don't know why we're constructing. No. It returns. This is the closure. Returns a finished. Okay, whatever, right? Like some API. And the delay that was provided by the implementation of policy.
Yeah.
Fine. Okay. If we shouldn't retry, right?
Mm-hmm.
Then we give up. We pass on the error.
Yes.
Cool.
Yeah.
Yeah.
Yeah, that's pretty much it, I think. After this, there are just tests.
Awesome. Wow. I was a bit concerned that this would be somewhat complex.
Yeah. It's
I'm somewhat relieved. This doesn't seem like, I mean, I don't want to write this from scratch.
Yeah.
But like, if what I have to do is like maybe copy paste a lot and figure out some of our own logic, that seems doable, right?
Yes.
All right. I'll be back in a moment, okay?
Mm-hmm.
I'm back.
Yeah.
Fine. I think we can resume rotation.
Hold it. Mob. Wait, do I? Shows there are changes, but there are no changes. No syntactic changes.
Well, I remember you editing and then undoing something.
Yeah. Or maybe it requires saving.
Maybe it formatted everything.
Oh yeah. Just revert that. Mob next. No changes. Yeah.
Cool. Sharing. Shared.
Yeah.
Well, we have a catch error, but we have copy pasted from
Which?
map, I
Oh, from
believe,
map. Okay.
because that was before we got that tip from from the maintainer that retry is the right thing to look at.
Yeah. Yeah. Now that we've read it, not sure if I can draw a parallel yet. But yeah, we'll see.
Well, we did this part.
Mhm.
Observable local throw error, some error, catch error. This is the operator.
Yeah.
And we get the error, and then we map it into a local from iter that has a string that does this error. It'll be some error, and then a string after to prove that we can recover from this, right?
Yeah.
Let mute result equals vec new, observable subscribe, result push, and that's when we can assert result is like that. Make sense?
Yes. Yeah.
Of course, syntax highlighting fails at some point. Who knows why? I don't know why. So, and I don't know why. I know we noticed an alias on some other on whether it was map.
Mhm.
So maybe I don't know. We just put this here. And we said, I don't know why we did this.
Derived clone.
Pub struct catch error of S and F. Pub source. You know what? This is a bit small for me. About that. Let's try this. Source. Yeah. source
Mhm.
and func. And we said that we will subscribe to the subscribe to the source, and then when on the first time that it errors, we will call the function and like
Yeah.
replace.
It's more like a select or kind of func, is it?
Did we take switch? Maybe we took switch map instead of map. I bet we took switch map, not map. Map observer wrapper for I think we didn't touch the comments yet.
Mhm.
Catch error observer. We said there would be a pub enum catch error observer. It will be generic on stuff.
Mhm.
OT. Do you want us to like retry, compare this?
Yeah, retry is a struct. Retry observer.
Observer. It has one source, but we have like the replacement. And the replacement may have a different error type. Does that make sense? It cannot have a different item type, but it can have a different error type. Does that make sense?
Mhm.
Because the consumer will never experience the original error. Does that make sense?
Yeah.
As an error, they will experience it in their closure.
Yeah, because catch observer replaces the source, right?
Yes.
With another observable. Yeah.
So I don't know if this is correct way of doing it, but we can compare.
Mhm.
It seems like we're missing some context, I suppose. I don't know.
Yeah. Sharing screen.
I also don't mind like mostly starting over because I don't think we made
Yeah, just
this
what
progress is good.
that's what I thought. I think because we were recommended to look at retry, we could just copy that and start from
The
there.
only thing that has has a little value here is that doc test.
Yeah. Oh, the doc test, you mean? Okay. Yeah.
The doc
Sorry.
test.
Yes. Yeah. This one. Yeah. I could copy the entire retry stuff at the bottom and then remove the stuff that we don't need from above while keeping what we need.
Yeah, do whatever.
Yeah.
Result matters.
So I'm gonna copy the entire thing. Go back.
Oh, I see what you mean. Yep. Yes.
And we don't need any of these, right?
I don't know. We can just start deleting things. I think we want to like keep stuff here for reference, the comments, so that we could replace them with the appropriate things.
Yeah.
Oh, you're pointing at no. Really, the only really wants to like go. I don't. No, I really do think that this does not require any review, like just from memory. Like the only thing that we are quite certain about here is the dog test.
Mhm.
Otherwise, it's like I don't know. It's like not. I don't think it's has any value. We just changed some names, like tried to figure things out.
Yeah.
If anything, it'll have more value to just do it again.
Okay.
Think about it again.
Right. So just keep
But
the
if you want to
doctors. Yeah.
keep this in a separate file. Keep this whole thing in a separate file.
Okay. Yeah. I'll just undo what I did and copy this whole thing and put it in a separate file. New or open source ops. Just call it catcher or initial or something.
First attempt.
First attempt .rs and put that here. Okay. And we go back and I can now safely delete the entire thing and get some, go to retry or maybe split retry and this file and go from top. B split and oh no. Oh no. Yeah, I think it's this, yes. And then open catcher or on the right. Right. We take all of this.
Yeah, everything.
No, yeah, everything. Okay. I know I keep doing this. Yeah. Paste that. Uh-huh. Yeah. Okay. Buffer close. Where do I? That doesn't close. Keeps. Oh, keeps putting other buffers here. My bad. Just close this. Oh, it's just queue. All right. Catch error. Yeah. All right. Retry operator implementation. I mean, do we just go with implementation and not worry about the comments here for now? Custom policy. We don't need retry policy, so I think we could
Sorry,
delete this.
I lost you for a moment. Did you say, do we go with implementation and?
Oh, I said we could skip the, I mean, we could leave the doc comments for now and then go with the implementation or do
Yes,
the,
just bring in the one doc comment that is
catcher or first attempt.
actual test.
Yes. This bit.
Yes. And above what is it?
And above, what is it? Let's
Above
see.
what item? What item is it on?
Catch error.
Okay. Then it should be above retry.
Above retry. Yeah. this is policy. We run config policy. Yeah, here.
Yeah, struct retry. It's interesting that this one has no. We'll figure that out later.
Yeah. And this will be catch error instead. Right. Let me just rotate. Next. Yeah.
Sharing. Shared. Okay, that's the original retry. And on the left is catch error. So starting from the top, I'm going to skip all this common stuff.
Yeah.
And
You could
I'm
delete
going
the
to
policy. But yeah.
comments here. Retry policy. Can I use
LSP? No.
too much?
Yeah.
I'm not sure what the deal is here.
Mm-hmm.
This goes. That's the config goes.
Yes.
Import for config. Import config.
Yeah.
Default for config. Whatever this is.
Yeah, this stays.
Okay.
Rename.
Catch. Well, I think we should probably do this, right? Let's see. Yep. Applied. We're not going to have a policy, but we are going to have something here. So let's just delete the thing we don't need and see see later. But what we add I think it's going to be some function, or we'll see. Maybe we don't. I don't know. We'll see. And we're going to have a
Catch error observer.
I mean, maybe, right? Maybe because this, okay, and this doesn't have two generics at the moment. This shouldn't either. So catch error observer.
We won't have S, right? So S for source.
I don't know. So I can't imagine stuff like
Because
I'm
we
kind of
replace the source. We replace the source, right? So the observer shouldn't. The observable
need
will have the source. Yeah.
the observable. We have this one. You can tell that, like, I don't see what you're. I don't quite see what you're saying.
I was going by the definition of catch error.
Yes.
That it is meant to replace the source with another observable. So I assumed that the observer
But
will not
you
deal
see
with
that
this.
it does not replace it immediately. It actually subscribes to it,
Okay.
right?
Yeah. Yeah.
In case there's an error emitted, then the function is called to replace.
Okay, yeah. That makes sense.
Maybe we will internally use this switch map operator. Or maybe not, because like this is where we kind of use lower level things. So I am kind of thinking we should go to the implementation of observer, because that's where we have the next error and complete.
Mm-hmm.
That makes sense?
Yeah.
Let's at least remove, I don't know. Well, this is it, right? So I think in all cases, there needs to be an observer, right?
Yeah.
There needs to be an inner observer, right? Whether it's the original one or the replacement.
Mm-hmm.
But since the original one and the replacement are different types, right?
Yeah.
We could either have an enum, or we could use type erasure. I don't even know that we could use type erasure, because they're different. They're actually different. They have a different error type. So I don't know that we could do type erasure, right? Because the type arguments would also be different.
Yeah.
So that's, I think, one fundamental question about the implementation here, right? Like, how do we store this fact, right? Like this observable or the replacement? What do we call it? Original and the substitute.
Mm. Yeah.
Uh,
Sharing screen.
original versus, what are the terms that we should use? Original.
Source replacement or some.
Fallback? Nee.
So you don't fall back.
Recovery seems nice, because this error recovery, right?
Yeah. Shared.
Yeah.
Start.
I think substitute is the best that I can come up with right now.
Yeah, substitute. Substitute is fine. We were at the code observable. Yeah, here. Right. Not here. The error retry. Yeah, observer implementation.
So we need to figure out this self type in its observer field, right?
Mm-hmm.
And in here we can always, like, I'm inclined to try using an enum. Does that make sense to you?
For the observer? You mean enum for an
Yes.
observer? Or? Okay.
I mean, what other fields? I mean, if that's the only, if there are no other fields, then maybe the self can be an enum. But if there are other fields, then only that field can be. See what I'm saying?
Yeah. I suppose.
So can you show us retry whether the observer struct current? So we are kind of looking at it. So show us the observer struct.
Okay.
Retry observer.
This, yes.
Okay, policy is irrelevant. Let's remove that so we're not confused.
Policy attempts.
But we have our own. Yeah, we have our own, right? Our observer needs to hold the function.
Yeah.
But the function should be held on one of the variants because only one of them will have a function. We can drop the function after we use it, right?
Yeah.
In fact, it'll be a function once, so that we could provide that flexibility. That makes sense? Okay, so that's not a field. Function is not a field. But and serial subscription is also not relevant because it is very specific to what retry is, right?
Yeah.
And also the subscribe function is also part of that mechanism, right? So let's remove those.
The subscribe function?
Yes, and the serial subscription. So, and what are we left with? We're left with, the inner, the source, right? Source observer. And whatever the heck observer context is, right?
Yeah.
So here's a question. This is separate from the source, right? So that it's like the context. What happens to the context when wrapping? Can you see is that a good question to ask? Like, why isn't this simply a part of the source, right?
Yeah.
Is it because S is simply observable type, not core observable? Like one below, like 160, line 160. S is simply observable type. It doesn't have context. The context is held. No, this is observable type. No, that's not the correct. Catch error observer.
This
S.
one.
Yep. Yeah. S is observable type, and there's a different. So context is held separately. So yeah, we do need a field, right? For the context. So it's not going to be an enum on its own, is it?
Yeah. Needs to be
It's going to have a
struct.
field that is an enum.
Yeah. Oh.
Okay, so we've made some progress.
We don't need to speak policy.
Okay, so let's make that field.
In catch error observer.
Okay, so, yeah, observer, yes, catch error observer. See,
Serial.
no, it's not going to be another field. It's going to be the source. It's just that source is not going to be S. Source is going to be an enum. It's like something like catch error source.
So there'll be like a pub enum.
I don't think it's public.
Okay, just an enum. Catch error source. Something like that. And what will the variance?
It's like before the. I'm not transcribing. I'm just saying one of them is. Do you understand, right? One of them is
Mhm.
is like original, and the other is substitute.
Oh.
Or maybe those are those original and substitute. Original holds a field, one field. No, it's actually not one field. Let's make it named, because this is the one that needs to hold the function.
Mhm.
So make named fields original, and then the field can be maybe source.
Okay. Oh. Hold on.
What?
FT. Mock text.
Are we on the same page there?
Yeah.
There.
I still. Okay, we'll see. Maybe I'll get it
I'm
in a while.
changing this to source,
Uh-huh.
and maybe this will be source because other things here, right? Spelled out. Source will be an S, and F will be the I think, yeah, F will be maybe we can get away with, like, I don't think we can use an impl in this position. I think it's just like F. And substitute would be. So I think because you can do O and S,
Mhm.
original substitute
Mhm.
in this case, right?
Yeah. And then the enum will take the type parameters.
O, F, S. Where? I don't know that
Bounds.
this is where the bounds should be, right? I guess
Yeah.
maybe it should be in some implementation. We can find where to put those, right? Later.
Mhm. Yes.
Cool. So this is a catch error source where we need an O, F, and S, right?
Yeah.
And therefore we need an O, F, and S here, right?
Mhm.
And then we can go to the implementation of observer, right? Where is
Yeah.
it? Catch error observer. But hold on. This is the type that we just added, right? Okay.
Yeah.
I just wanted to find references. Right? Look type, simple observer. This one.
Uh-huh.
Okay. And we said what? O, F, and S. P is
And no
policy.
P. Yeah.
O, F, S. Okay.
Yes.
Item is item, but air we have two. But here we have only one, right? I don't know. At this point we have only one, I think. Maybe. No.
I mean,
Hold
we'll
on.
have the
No,
original
this is
error
not
and
correct,
substitute
because
error.
Yeah, but where? I don't know yet, so let's just ignore that.
Mhm.
I think we can just ignore it. So okay, so um, l- what is closed, right? Let's do complete because I think that's trivial, right?
Mhm. Yeah.
So it's basically, you know, we call complete on this. So, but oh darn, that's an observer context. How does that work? What's going on here? Like, why is this? Why is this? There's an observer.
Yeah.
I'm confused now. Observer
What?
context. What? Like this field
Uh-huh.
is that.
Yeah.
But so how does this? How does this? When you call something on it, how? What do we? I don't. So I think I lost context of how this is what the contract here is. This is an observer, implementation of observer, right?
Mhm.
And an observer, when it receives complete, it needs to it when complete is called on it.
Yeah.
Let's talk about next because it's easier. When next is called on an observer
Mhm.
by some observable, right? Then it can handle that, right? Here's how it handles it. But what this does is this because of the RC?
Not
It
sure.
calls it calls next on an inner observer, right?
Mhm.
All the while, self has like source. I mean, we should probably read the original. Instead of reading it after we modified it, right?
Yeah. Sharing mobstat. You wanna read the retry?
Yes, because I can't.
Uh-huh.
I thought there's like a relationship between these fields, and maybe the relationship is some RC, right?
Yeah. It is this. No, not here. Yeah.
Yeah. So next calls next calls observer next, right?
Mhm.
But let's go to self. Type. Go to
Yeah.
type.
Yeah.
There's observer or observer next. Observer is observer context.
Mhm.
So what is source? Go to the implementation again and see what source is.
Source is there's no bound on S.
No bound.
No.
So source is an observable. In other contexts, in other implementations, source is an observable.
Yeah.
Observable, not observer. Right?
Mhm.
Okay. Yeah. So there's some kind of a two-way. There's one field that represents, again, because it's wrapping a relationship,
Mhm.
right? Can we see map instead? Map operator. I think that's the simplest. Map observer. This is, okay, so map has only source and func.
Yeah.
But map observer has observer and func.
Mm. Yeah, this is also kind of this also is similar to what I said, right? You drop the source here.
Well, there is no source.
I mean, there's no source. Yeah.
The map struct has a source,
Mm-hmm.
and the map observer has only an observer.
Yeah, because it wraps another observer.
Well,
That place.
well, show this side by side with retry.
Mm-hmm.
Here,
Split and retry and retry observer. This is long. Ah, retry. Yeah. There you go. I think the structs will be similar to map for catch error, but the implementation will be similar to retry. Sort of. That's what I feel.
you may be right. Yeah. So let's try that. So what does that mean for our catch error observer? Can you pull that on the right?
Yeah. Catch error observer. Yeah. So that
Maybe
means
has no source.
yes.
And look at that. Like, maybe it has no. What is that, right? Like,
It should have f, right? The function, because
yes, but maybe what we call currently catch error source is catch error observer. Maybe it's just an enum.
yeah.
We can try that, right?
Mhm.
So let's take that enum and like paste it over the catch error observer and rename it to catch error observer.
Oh, so you just want me to replace that here, like put that here and remove this.
Remove the where clause
Mhm.
and delete the original enum.
Mhm.
And remove the final.
It's still a struct, or it should be an
enum,
enum, right? Yeah.
and it's not pub. It is pub. Enum, and remove the parameter.
This.
Okay. Now can we go again to the implementation of observer for this?
Impl. Oh no. Just look for observer. I can just look for implementation, so I can't. Okay. Let's scroll down. Yeah.
Okay, let's look at complete.
Let's look at complete. Yes.
Okay, on the left, let's look at complete.
Mm-hmm. Oh.
What?
Oh no, my bad.
What?
Yeah. Right. Let's look at complete. Oh, it's right here. Yeah.
This is map, right?
Mm-hmm.
You there?
Yeah, yeah. That's just come up next. Right.
Just a moment. Okay. Sharing.
Mm-hmm.
Shared. Do the same thing on the right. We have catcher. On the left, we have ox map.
Mm-hmm.
Ox complete. Complete. So I think this is because we have an enum, right? So these will always be like match self. All right.
Yeah.
So will this be like source complete? And substitutes complete. Maybe this one. This doesn't return anything, does it?
Uh-huh.
Will this be similar?
Yeah. Closed. These closed. And the same thing for next, I think. Yeah. Because we remove the attempts and stuff. So it'll just right.
Maybe.
Mm-hmm.
Okay. I don't like that like everything is erroring here, right? So let's try to fix that. Maybe there's no context now. Okay. I don't know about clone anymore. I don't think it's a thing.
Yeah.
I don't think we have this anymore either. I do think we have some other things, such as, well, O is an observer, right?
Yeah.
S is an observer, right? Sorry. F is a function once that takes the O error and returns S. How's that working for us? These need right? What does this need? Item and error. Okay, that's easy, right? And these are positional. These are positional. So item is item.
Yeah.
Apparently, we need the original error in this scope, right? I mean, because we need to pass it here, right? Like we can't do this. It's not allowed. So we need to do something like O error, which will probably be better. Original and original error, right? And maybe the item should be first. Original error, function S, and then S error. Does that make sense? So this has O error. This is S. This is item and S error. How happy are we now? Associated type error not found for O. What?
Not found for O.
You can't grab there's no such thing, right? But we don't need that because we have O error. Is that okay? This does not exist. This is S error. Maybe this is progress. I don't know. Okay. So look, these are not crying. None of this is shouting except for that this is unused. So we can do that. So we have error. This is where the meat is, right?
Yeah.
That looks like fun.
Yeah. Sharing screen. Upset. Okay.
But for the noise. All right.
What is
What
this?
you got?
O error is not constrained by the by the infiltrate.
It needs to go somewhere, basically. I think that's what this means. I think it probably needs to go to catch error observer. Maybe. I don't know. It's not constrained. It goes somewhere. What is it? Show me the error again, like, because I don't understand these errors yet.
Yeah. Show me the error as in the error function.
the error again. That error we are talking about
Oh.
O air
I
is not constrained.
this error. Oh yeah, right. Yeah. It's not constrained by the impl trait. Self-type or predicates. Unconstrained type parameter.
This kind of like feels like a warning that has been escalated to an error, right? Like, I mean, why does the compiler care so much that this is not constrained? I don't know.
Yeah, me either.
Sorry, I'll be back in a moment.
Yeah.
All right. So can we get more like clarity about this general thing of not constrained? It should have like a number E207.
E0207. E0207. Rust.
The type, const, or lifetime parameter that is specified for impl is not constrained. Erroneous code example. Start foo impl t is default foo. Get function get rep takes ref self returns t. And then we're trying to call default on t because we know it's default, right?
Yeah.
But we never find out what t is. We never get to actually find out what t is. Does that make sense? Like, that's a problem I can see here. Because the calling code cannot specify t by constructing a foo, right?
By constructing a foo. Okay, yeah.
But I think it can specify T by calling get and using inference in a, putting the return the return of get in a position where T is declared somewhere, right? The type of T is declared.
Mhm.
But I think that's like maybe insufficient.
Yeah.
Like there has to, like, maybe if you declare, I don't know, get on T, T on get instead, for example, that would
Mhm.
probably be fine, because then
Yeah.
you'd always be able to declare T on get when using get. Any type of or const parameter of an impl must meet at least one of the following criteria. It appears in the implementing type. Okay, that's easy enough. For a trait impl, a trait impl. Okay, in our case, it's a trait impl, right? It appears in the implemented trait. Okay.
Uh-huh.
It is, or the third, it is bound as an associated type. Okay. Any unconstrained lifetime parameter of an impl is not supported. If the lifetime parameter is used by.
If the left.
Well,
Yeah.
that's about lifetimes, but we're not. And then we get error example 1, error example 2. Okay, maybe we can take a look at our code again,
Mhm.
and I don't know.
Oh, there is no changes.
Shared. It's like it's like pointing out some unsoundness here,
Uh-huh.
right? Like, I can't believe that this would happen with and while we are actually making sense. Like, we must be not making sense.
Mhm. Yeah.
Like, for example, this observer trait. Why is it substitute error? Shouldn't it be observing on the original error?
Huh. Yeah. I think you're right.
Like, isn't next? No, isn't isn't this function error? Like, what is this? I mean, what the heck is this? Look, I mean, what is it here?
That is the original error.
Yeah.
Yeah.
I mean, even if there's only one, right? This is the original error. This is what we will be dealing with. So
Yes.
maybe we've figured out that this needs to be
O error.
O error.
And
Yeah. S error is not constrained. Of course, we need to go here, right? And say something like,
O error.
this is O original error. Cool. Okay. What about This is probably just like that, right?
Mm-hmm.
Okay. This is not constrained. S error. I mean, it goes into line 209.
Yeah.
But hold on. Like, no, I don't. Hmm. Well, supposedly we would use it. Say, does it like? Is it never? It's just never used here. Well, yeah, we need it there, right?
Yeah.
Is the maybe this does not need to be constrained here? What if we don't constrain it?
Maybe the catch error observer is not meant to have the source error. It's not meant to
The
pass
catch?
on the source error.
Pass on? Sorry, what are you saying?
Oh no, I meant the O, the O type parameter is not. Oh, no, that doesn't make sense.
Maybe this is correct, what I just did. Like I deleted the constraint here,
Okay.
right?
Yeah.
And it simply is not, it's not mentioned.
Yeah.
Maybe that, I don't know, maybe you don't need it. Like we can try now to like do something here, right?
Mm-hmm.
Try to do something here. What's the problem complete now? Okay, well, what the heck is, wait, what is this now? Okay, well, we can't do that. Now it's not constrained, right?
Yeah. It's not an observer anymore.
So maybe we need to do that. And obviously it has its own error type, right?
Yeah.
So we, like, seems like we need this, right?
Mm-hmm.
So it needs to be constrained either on the struct or on the trait. Maybe it's the trait. Maybe, I don't know, maybe it's this. Like, but this doesn't,
Yeah.
we're not going to change observer,
Yeah.
right? And this is obviously O air. So I don't know, maybe like we are forced to stick it in here somehow.
Mm-hmm.
Like, I guess we need to do this. No, this is never used, so we need to say something. We never meant to use it there. Now we need,
Yeah.
I don't know, that doesn't look right.
I don't know if let me start the timer. Yeah. I don't know if it's a good idea to have substitute like this here. That is storing the observer, substitute observer, because we won't be doing anything with that here, right? In the catcher operator.
Will we not need to do this?
We just have to
You have
call
an
a function
observer.
that provides the replace substitute, right? And not really do anything with the
No,
substitute.
this is a chain of observers, right? And hold on just a moment. Where the substitute is not an observer, it's an observable? Are we dealing with the wrong thing here?
Yeah. Yeah, I think substitute should be an observable.
Observable.
Yeah, that's right. Yes. Not an observer.
What are we doing here? Catch error observer. Can we go back to the implementation of observer?
Yeah. It's right here.
That's not what we need to do. It's not. We're calling next
Yeah.
on some observer, on some single observer that we.
This needs to be an observable. Something like
Observable type.
observable and then observable type. Okay.
Well, I'm not even sure that this even takes place. Any of this takes place here. I'm not even sure this is the implementation in which this stuff takes place. Yes, we in our handling of an error, we need to do something. Yeah.
Yeah.
But in our next, there's nothing to match on. Is there? Or
Yeah,
we're
there shouldn't be the only thing we need is the observer, right? And
yeah.
which is the source.
It is the thing that called next.
Yeah.
That we have replaced.
Mm-hmm.
That we have possibly replaced, right?
Mm-hmm.
So it is not observer that is possibly an enum. It's the other struct, right?
Yeah. Yeah. The observer has to be the struct, the same as map.
Can we start over?
Yeah. Okay. I just have to replace this with a struct, right?
No. Oh, I don't know.
So essentially, I just go to map.
I'm thinking to start over completely.
Okay. Yeah. You mean like delete the entire thing again?
I think so, because I don't want like any of the wrong things we did here to persist. I don't want like, how many universes do you want to consider?
Yeah. So now do I copy from map or retry? I think map is the structure is more like map, but implementation is more like retry.
What did we do last time?
We copied from retry and then try to replace it. So like map.
I think retry.
Okay. Retry, copy all of it, go catch error, paste it again, and yeah, retry observer, and yeah. All right. So we're back here. You can start from here, retry.
Rename this.
Yes. Rename this to catch error. And we don't need policy.
Correct.
Okay. And rename this to catch error observer. So no policy again. If we don't have policy, observer, yes. Attempts, no. Serial subscription, I'm not sure.
That also very much like it is part of retry.
Yeah. So these both also. Yeah. Okay. Then yeah, over here, so P goes. Yes. Let me just rotate really quick.
I think we're still in the stage of breaking things rather than making them work.
Yeah.
Share. Shared. This thing.
Yeah.
I don't think this is clone.
Clavis source.
This source is an observable.
No, that's observer. Right.
That's
No?
observable, right? Look, where is this implemented? Observable type. See?
Oh yeah, yeah, okay. Yes, yes,
And that's the thing we will be replacing.
yes.
But there is a scheduler.
So
here.
instead of a scheduler, we need a function there. But yeah, it can be called.
You think we don't need the scheduler?
I-
Let's see.
We do need it, but I mean the naming. I just meant the naming is wrong.
Actually, I don't know. Currently, I can't find where it's used. Let's go to retry and see where that is used.
It's used to schedule the tasks.
I can't find it though. I can't find the references to this.
I think if you look for task, you might find it there.
I literally cannot find scheduler.
Yeah, this is what I meant. Yeah.
This thing? Why can't
this is where.
Can't find this. Do you think that this is it?
Yeah.
But this is a method call.
Right.
Hold on. Can we delete that field? Can we delete this?
Mhm. Oh no.
Fine, yeah, no, don't worry about it. Hey, well, it's somewhere else, right?
Mhm.
The heck is this? Self-scheduler. This isn't a, yeah, okay. No scheduler. Huh?
What?
Hold on. Hold on just a moment. I'll try to remove the other changes, right? Reset. Status. We have modifications to map for some reason.
Mhm.
Let's try git restore p observable. This is formatting.
Yeah, it is.
I'm restoring this.
This
Restoring
is
that.
also, and
Restoring
this.
this. No, not
Not
restoring that.
this. Not this. Yes, formatting.
This I will stash, not restore. The heck is that? Map. This is all map. We didn't mean to change it.
I
Also,
think we
I'm doing
should remove
all.
rust fumped from the NVARC.
Really? What file is this? Retry. We didn't mean to edit retry.
This is a formatting.
We did mean to edit retry, but not this.
Yeah.
Not this? Yeah. No. Was this
We need
together? Okay. Have to do this again. Is there undo here?
go to the previous hunk.
Undecided hunk. Okay. Okay. Split. Restore.
Mhm.
No. 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 No.
No.
Okay.
Yes.
Okay. Stash. Push. P. No. Yes. Yes. No. No. Cargo test. Oh, there's another commit. Yes, push that. Oh, that's formatting. Darn. Restore T. And yes. Cargo test. Huh? Okay. Let's make a PR.
Yeah.
Um, git stash push retry no scheduler git stash push u catch error new files. Mr. Fetch which C retry no scheduler field. It's slash list, it's slash pop, stash add 1. Diff
Yeah.
more than
Exposure.
scheduler field. I think there's also
There's unused inactive code, right?
this. Oh, it's here. Huh. It's not only an import, it's whatever the heck this is. Do you think it's for some effect?
Not sure. Oh, we could, since the tests are passing, we can just create a PR and ask them.
Because that's what the scheduler does, right? It's not. It's a mechanism, right? And then the scheduler maybe is kept on. Yeah. Let's do it. Let's ask. Darn.
You could just remove Rust from the.
Yeah, I'll do that. I mean, we should probably enforce formatting, right? That's frustrating. Oh boy. This is a no. People who don't use a formatter, who are you? Are we good now? Add P. This.
Format, no.
That. Sorry?
No. Yeah, it's good. Nothing.
Back. Okay. If scheduler field sure. Scheduler sphere. Retry? No. What was that?
Yeah.
Yeah.
It's retry.
I mean, like the fact that the tests are passing is like, the very least doesn't make me comfortable with the tests.
Yeah.
So I noticed that I can remove that. This field can be removed and cargo test still has this. By the way, is this the only way to like test here? What do we have? They have something else?
Not sure. No.
Do we have like just something?
No.
Well, I don't have just.
There's no just file.
Nah. That's just cargo test. Okay.
And this is also like a library, right? I would expect it to only have cargo test.
Okay. I understand that a scheduler performs effects scheduling. So I like kind of expect you to tell me that yes needs to be kept alive within this field. But if that's the case,
The tests are lacking.
we wrap it up in more words, different words. Should we make, I mean, this depends on how easy such tests are to write and whatever.
Yeah.
Like, how
would we test it?
like
How
how
tribute?
yeah should like can that be tested?
Yeah.
Covered by also I kind of want to see whether there are others, right? Scheduler column fields, other stuff.
Might want to look in ops.
Sure.
Yeah, delay has
I don't.
SCH, delay ops.
You saw the line?
Yeah, ops/delay. Yes.
Debounds.
Debounds.
Scheduler. Connect. Scheduler. Uh-huh. Yeah. Kind of sucks. Tests. Okay, so let's also like mention this.
Yeah. You might also want to mention. Might also want to mention that this was while trying to explore retry for catch error. Maybe that's relevant. I don't know.
Probably no.
Okay.
I also notice that we understand that a schedule performs come as such fields in delay and bound, which makes sense. But if that's the case, can that be covered by can these, like, I don't know, fields have a coverage? While working on, I don't know, what I got used to studying towards catch error.
Yeah.
Okay.
Looks good.
Well, I mean, it might be a race condition, right? And that this success is the race.
I mean, we also noticed that it was in delay and debounce, but we didn't check if the scheduler field itself was accessed in delay or debounce. Because in retry, we saw that the field was not accessed, and that's why we decided to remove them, right?
Debounce. That doesn't work. I don't like that. Like too many scheduler. Whoops. Well, this is construction. What am I looking at here? That's a
References.
debounce. Why? Oh, I see. I'm jumping from this to that, and then this to here, which is not the same thing.
Yeah.
God. Okay. That's unfortunate. Okay. I wanted to keep jumping from one thing to another. So
Yeah.
I don't know how to do this. Search for references. It's only ever
Yeah, it's here. This is it, right?
scheduler. Yeah.
And the self is what? Debounce observer. And the field is also on debounce observer. So, sorry, yeah.
I don't think we should spend any more time on this.
Yeah.
Just
I think you can
send it.
raise the yeah.
You want to say this? Physically removed and cargo test still passing. I wonder whether it'll actually pass. It's pretty quick. Guess that's what happens when you don't use Nix. When you don't use without nicks, things work very well when they do.
Well, yeah, I mean, most of even the slow Nix CIs are because they spend a lot of time installing Nix and all of that, right? Because they don't come by default in these runners.
But you get what I'm saying, right?
Yeah, yeah.
These are the tests.
Yeah,
There we
looks
go.
good. Yeah.
Shall we take a formatting now?
I think it's good to mark it as ready. Code coverage.
Yeah. There we go.
Nice.
Shucks, I
Yeah.
didn't. Hold on, I didn't tag you. Okay. I need to do things here because I have stashes to look into.
Zeroed stash.
There are two actually, right? Stash pop, stash pop. Ah, and another one. Yep. There we go. And then git stash push. U. And then I think actually, hold on, git stash. Let's look at stash pop and then I get like a git stat reset at upstream. And then like there will be less to. Did it like fail to do that? Because V1 integration shouldn't have. Oh, is it? Oh, reset. V1 integration shouldn't have a diff now. It doesn't. What's going on here?
Yeah, I
What?
had the same problem before. I had to revert that file manually. There's
Huh?
probably some extra new line or something. I don't know.
No X diff.
Oh, it's formatting, but it doesn't show up in the
Well, because I use
difftastic.
difftastic. So.
Yeah, yeah.
Wait. So what? So what does this mean? I can just remove this, right? Git
Yeah.
restore p
V1
test
integration.
and then restore that. Okay, good with this now. And now we can do a git stash push u mob start git stash.
Damn. Sharing. Interesting. So mob start.
But we don't need a scheduler.
Yeah, but we do need a transformation function, right?
Yes, which again means that this can become just an enum. Basically the enum that we had, right? But it's this struct, not the observer struct, right?
By making it enum, we are saying catch error will be either a source or a transformation function?
Not either well, do you remember the enum we made?
Yeah, original and substitute, yes.
Yes. And the original will have the function.
Right, yeah.
That.
Yeah, okay. Yeah, makes sense. So do you want me to make that now? Or okay.
I mean,
Enum, catch
do you have anything
error.
else to do?
No, I meant change something else
Not
in the
as
implementation and then come back.
Do we have anything else? Can we? I mean, we have something to possibly edit, so let's try to make an edit.
Okay.
So source has so no source. This is original and substitute.
Yes. It's the original named field source. This will be S, and then a function f, and that will be f. Just rename this to f, and we'll have a subs.
S is not S anymore, but go on, do it at
Okay.
your
Substitute. This will be something. It'll be whatever f returns, right? But
this will be this will be S.
This will be S. Okay.
Source will be O.
Okay.
OFS, I would say. That's what we did.
Yeah. Okay.
Okay. Can we look at so
The observer.
Observer.
Yes. This will have
I would look at the implementation of observer for this.
Here.
Yes. So let's take care of the signature. What do we need for catch error observer for its types?
We don't need P. We need S.
Need
Context.
OFS.
OFS.
Oh no, I'm sorry. This is observer.
Yeah. And
can we look at the observer of like map? Does map?
Yeah.
Does that take context? Map observer take context?
Yeah.
No, it does not.
No.
Okay, so I don't think. Do you think we need context?
Maybe not. No. Wait. Not sure.
I'm not sure, right?
Yeah.
I'm not sure. What is context used for? In retry. Can we see that? Find that field. What is it? Retry observer.
Retry observer. Yeah, this. And
it has an observer. Serial subscription. That's what it needs the context for. I don't think we do. Do we do that? What are we going to do? Like we are going to keep a subscription and like we're going to keep are we going to keep a subscription? What happens why does map not keep a subscription, right? Because subscriptions can be dropped. What does this do with the subscription that it keeps?
Clone it. And then do what? We can check that.
Well, I remember this, yeah.
But I don't understand why exactly is that necessary.
Does dropping a subscription unsubscribe? I don't think so. Does it? Is that the case?
Yeah, that explains why they're storing active subscriptions in serial subscription.
What it doesn't explain is why none of these other, right? Why
Yeah.
does not why doesn't map store a subscription? So this, let's try to get away with not having a subscription.
The okay, like the serial subscription. Okay. All right.
What file is this?
Oh, this is still retry, but I go catch error. Yeah. Catch error observer. Yeah, we were seeing why we need the context, but we need the context for the observer, right? And not just for the serial subscription.
What is source? It will be the
Observable.
observable, right?
Yeah.
Is that
And
true though? The observer stores source for that observable. Okay. Okay, so that will be our enum, right?
yeah,
Okay. So we don't need that context, right?
we don't need the context. Yeah, perhaps we can try it without. Rotated.
Shared. Okay, on the right is catch error. Here's the observable that we think we don't need, which also means we don't need that, right? Which also means there's no policy and there's no such thing. Are we right about any of this? I don't know yet. There is no such a thing. And that seems to check out. Now, where do you want us to go?
Yeah. So we have catch error. Maybe we can remove the unnecessary stuff. Like the things we obviously know is not.
From this? Don't you want to go to implementation of observer here?
Yeah, yeah.
Like this?
Mhm.
Remove that, remove this. I don't think self needs to be cloned. There might be trait bounds, but we don't have policy. We don't have, I don't know. We do need an item and an error to pass them on to the observer, right? We don't need that. And we probably also need to establish a relationship between S and item and error, maybe? Well, let's take, I mean, S definitely needs to be something like some sort, because otherwise then we don't do anything with that field, right?
Yeah.
Can't do anything with that field. So S needs to be I don't know what it. Here's debounce, right? So does up P schedule H and V. Interesting. So P is an observer. Does that make sense that this is observer with a different error as we already did previously?
Yeah.
Like
No,
item?
S. Okay. Yeah, I'm
Is
not
it?
sure.
It's not an observer. So no. What do you think it is? Why do we have
It
this here?
is, at least in retry, it wasn't an observer. Right?
Source. What is this now? We don't have that. We don't have any bounds. In retry, retry observer, right?
Mm-hmm.
There's observable type for it, where S is an observable type. So in the
Or maybe,
I mean,
yeah, maybe.
let's see this again. Where's implementation of observer for that? I don't know why my.
Maybe
Did I
you're
just
right.
format it? Oh darn! I just formatted it.
Maybe you're right that S is observer in catcher observer.
Sorry.
Maybe you're right that S has to be observer in the implementation of observer. Yeah, that's probably right. Item and substitute error.
I'm not sure.
Okay.
I'm not sure yet. I'm not sure. Are you sure? Impl.
Something has to be an observer, and we only have S there. So
Is info observer for no. Heck. Oh, it's generic. Retry observer observable. This.
yeah,
Why can it call next on something? Because it has an observer.
Yeah.
Inside of it.
So we need a source, not a source, but we need something and an observer in the struct.
This, right?
Yeah.
Receive the next value from the observable. Receive and do what? What are we? We are a wrapper, right?
Yeah.
Catch error is a wrapper.
That's right. Yeah.
And it will wrap, and it will call next. It will receive next because it's an observer, or I mean this struct, and then it will call next on the observer on the observer that is observing it, right?
Mm-hmm.
Is that how it works? Like, let's look at map. Here's M observer for map observer. We say that O is an observer, right? Right?
Yeah.
Map observer has an observer O.
Mm-hmm.
And that's why we just call self-observer next with the function, right?
Oh, yeah. But in our case, we'll be doing self.source.next because our observer calls it the source.
So in the case of map, what is observer? What is self-observer? I want to answer that question, right? Like
Yeah.
how.
Yeah, sharing. Shared.
This will, like, we just keep, rubbing against this. It'll eventually scrape off.
Mm-hmm.
So map.
Map, RS. Yes.
So how is map observer? Show us the construction of map observer.
Go
Just find
to
references and find a construction.
references. This is
Impl.
impl. Yeah. This is construction.
Okay. Cool. Okay, so there's a thing called context transform. I saw this before.
Mm-hmm.
And look at the hover it. Where where are the docs?
Oh, yeah.
Transform the inner value,
Mm-hmm.
inheriting the scheduler. Used inside operators to wrap observers. Utility. I think it's not strictly necessary, but it's convenient.
Yeah.
Because it gives you the observer. You give it a mapping function that maps between observer,
Mm-hmm.
and then you can just take that observer and return whatever you want.
Yes.
And what you get is like the same context.
Mm-hmm.
What you get retains its context.
Yeah.
And this occurs in where is this called?
A core observable implement subscribe function of map.
Which takes. So this is subscribe,
Yeah.
right? So when subscribe is called,
Itself and context.
I don't know why. I don't know why context. Because context can be a subscriber.
That's where transform comes from, apparently, but yeah.
Context is a subscriber, I guess. Context implements whatever it takes to defines the execution environment, provides scheduling capabilities, blah blah blah, blah blah. Oh, look, there are combinators. There's three constructors, right? There's combinators. What are they?
Mm-hmm.
Transform, wrap, and swap. Oh, swap. Swap sounds interesting. Yeah, but we have different types actually. There are destructors into inner, into parts. Okay. So I've been informed that dinner is ready.
Mm-hmm.
So let's just try to understand this part.
Okay.
Like to remind ourselves what the method subscribe here, why it takes context and not like something called a subscriber, right?
Yeah.
Eventually, the only thing it calls on context is transform.
Mm-hmm.
And then we get a wrapped, which is again a context, of course, right? Because it's transform. And then we call subscribe again and this is a map. So we subscribed on the and so like so the answer is yes. Contexts are a context is an observer, right? Like what can subscribe? A context, because it implements observer. Right? Like what can you core observable takes context. So so context also wraps an observer. That's why, yeah. Okay, so like you don't subscribe directly with an observer. You pass in a context.
Yeah.
So contexts wrap what? Do they wrap observers or observables? Or maybe possibly like whatever, and that thing can be either or both or none, and then it's not useful. Like that these implementations pass through. Does that make sense?
Yeah. Think yes.
Mm-hmm. Okay. Awesome work, Shivaj.
Yeah. Good work.
Thank you for your participation.
There's nothing to comment, so yeah.
If this is interesting to you and you are very bad at it, or if you are awesome at this and already know this kind of stuff and think you can help, and so just message me. In any case, Shivaj, don't hang up.
Yes. Good
Until
work.
next time, be well.
Yes.